はい、それでは次回になりましたので、メルカリ Go 第27回を始めていきたいと思います。司会進行はペラニフが務めさせていただきます。よろしくお願いします。はい、Okay, let's start mercari Go 27. So, I'm Priyanikov, the host of today's event. Okay. はい、まずはじめに、メルカリ Go についての説明をさせていただきます。At first, I'd like to explain about mercari Go.メルカリ Go は、メルカリのエンジニアたちが、Go についていろいろ話すイベントとなっております。ハッシュタグメルカリ Go をつけて、X にポストするか、YouTube にコメントを残していただけると、発表者が、発表の後に質問に回答いたします。また、Go for Slack というパブリックワークスペースもあり、こちらのシャープメルカリ Go というチャンネルでは、ブログなどが公開されたときに、情報が共有されるので、興味のある方はそちらにも参加してみてください。mercari Go is an event where Mercari engineers talk about Go. So we can pick a post of X with the hashtag mercari.go or YouTube comments. So please post your comment if you have questions. And we also have a public workspace called Go for Slack, so where we share information on the Sharp Mercari Go channel. So if you are interested, please join this channel as well. はい。それでは、こちらが、本日のアジェンダとなっております。This is today's agenda. So, first presentation is Kim Biko-san, so writing profitable tests in Go in English. And next presentation is Task-san, GC24 recap interface internals in Japanese. And Restaurant-san, so GC24 recap, who tests the test in English.And final presentation is Akram-san. So Cloud PubSub high-speed in-app notification delivery in English. はい。という4つになっております。はい。そうしましたら、最初の、発表に入ります。The first presentation is Writing Profitable Tests in Go by Kim Biko-san. So, okay, so Kim Biko-san, so please start your presentation.
Hello, everyone. Today, I'd like to share with you how to think about testing in Go in terms of profitability. But first, who am I? Hi, I'm Kimbiko, everywhere online, and I work on the search team at Mercari. I've been writing Go since before context made it into the standard library, and I'm a big proponent of software testing. Today, I hope you'll be able to learn a novel way to think about testing, a framework for deciding whether or not to write a test case, as well as a bunch of tips and tricks you can utilize in your tests. I will assume that you already know how to write tests in Go, and I won't cover other basics such as mocking. But before we get too technical, let's start at the most abstract level. Why do we write tests in the first place? There are several reasons, of course, but the main two, I think, are to verify the behavior we expect is the behavior we get. Now, unfortunately, we can only test the test cases that we can actually think of. So, we're somewhat limited there. You might be familiar with fuzz testing to also test cases you haven't thought about, but let's ignore that bit for now. Usually there's too many input parameters, mock behavior, etc., for it to be realistic to test all real-world cases. And after a certain point, adding more test cases doesn't really make sense. There's not a lot of value out of it. In my opinion, a more important reason for testing our code is to gain confidence that it's okay to make future changes. In other words, to make the code easy to modify without breaking anything. The idea is that by having a good degree of testing, we can change the code with minimal changes in testing, as well as be confident that nothing is broken once the test passes after making our change. Next, I'll introduce a method for thinking about writing tests in terms of profitability that makes these abstract notions a little bit more concrete. I'm going to define a profitable test as the following. A test is profitable if and only if for the lifetime of the test, the revenue of the test is greater than the cost of the test. Now, I'm using the words revenue and cost here, but we'll get more into that in a bit. Some of you might see where this is going already, but let's explore this idea with an example to begin with. Suppose we're maintainers of a particular test. And for a minute, let's also pretend that we have some sort of magic ability that lets us see two parallel timelines. In one timeline, we saw all the issues that would have happened if we hadn't written the tests. And in the other timeline, we only experienced the chore of writing and maintaining that particular test. So let's take this kind of random fictitious example. And in the timeline where we didn't write the tests, we had to debug the code 3 times for about 15 minutes each time to understand some complicated behavior. We had to spend 1 hour in response to some preventable incident that happened. And not only did we have to spend time working on that, the incident itself cost, let's say, 100,000 yen of lost revenue for the business. Whereas in the timeline where we did write the tests, all we know is that the original author spent, let's say, 20 minutes to write the test originally. And then throughout the lifetime of the test, another 5 engineers spent 20 minutes each updating the test as it evolved. The total runtime was just 1 minute in total, and after many years, because Go is very fast. Like, the runtime of a test case is pretty small in the grand scheme of things. So if you add all that together, subtracting the cost from the revenue, as in the lifetimes on the left and the lifetimes in the middle, that comes out to 98,750 yen of profit for a single test. Wow, that's a lot, right? I'm guessing maybe some of you have picked up on a couple of issues here. In the previous fictitious example, we made 2 big assumptions. That you can somehow see both of these timelines, that you know both the cost and the revenue when you're writing the test. And we assumed that there was going to be an incident for that particular test case. So that's not really that helpful if you're a human like I am and not some kind of chronomancy wizard who can actually see 2 timelines. So instead, what we can do is borrow this idea of expected values from statistics and this idea of change failure rate from a book called Accelerate to help us get a better estimate of the profitability of the tests while only experiencing one timeline. Now, again, this is an estimate based on the expected value, so it's not necessarily accurate per test, but over the grand scheme of things, it will be more or less accurate. If we have a track record of, say, 10% of deployments having a failure, as in our CFR, our change failure rate, is 10%, which is not a excellent value, but it's a pretty good value, then our profit estimate of the test actually becomes much lower. It's only like 3,750 yen. I think this is a much more realistic estimate, but it's not necessarily a lot of profit. Note that depending on how much time you spend writing tests, you might actually end up with a negative profit. For example, you spend too much time over engineering, and as a result, you've spent a lot of time writing the tests when you probably could have gotten away with a lot fewer test cases. Also, by the way, if you're interested in learning more about CFR and other DORA metrics, I recommend that you check out the book Accelerate. It's a great read. All right, so let's take this idea of profitability and try to optimize for making our tests more profitable. And don't worry, I swear the Go code is coming soon. All right, so as in business, to increase profitability, we can either increase revenue or decrease the cost. It's also worth noting that in a product-oriented company like, for example, Mercari, tests themselves don't directly contribute to revenue. Like there's no end user that actually executes a unit test, right? This is slightly different in the case of consultancies or other delivery companies where you deliver software to an actual company. So, you might have to consider what kind of company do you work for and what is actually profitable in the context of your company. Now, assuming we are in a product-oriented company, what can we do? One thing we can do is we can increase the ratio of time spent writing production code versus time spent writing test code. Basically, shipping more features faster, but there are arguments why that might also be a bad thing. And we can alternatively increase the quality of our code to reduce the impact of bugs and incidents in production. And we can reduce the resource costs of executing our tests if they take a long time. Now, I believe the second point here is super important as well, but that is too large in scope for me to discuss today, so I'm going to skip that. And the third point is usually not a problem unless you hit a very large scale with your tests. So let's also assume that you can ignore that for now. Like, for example, running the previous test case would have taken like less than a yen to in terms of cost of CI. So for the rest of this talk, I am going to be talking about how to write tests so that you can spend less time writing tests. Because, again, we want to increase the ratio of time spent writing production code versus the time spent writing test code. Now, the first tip I have is empathy. When I was working as an engineering manager, one of the skills that I encouraged my engineers to grow the most was empathy. Learn to be empathetic with your coworkers who don't know your code. Learn to be empathetic with your coworkers that you haven't even met yet. Maybe they'll be hired later. Be empathetic with yourself a year from now. How many of you have looked back at code that you've written several years ago and you have no idea what you were thinking, you have no idea what this is doing? Let's try and avoid that. Let's try and be empathetic with our future selves. Now, will these people be able to understand your code as easily as you understand it while you're writing it? That is the question to keep in mind continuously as you're writing code. And just to give you kind of a rule to follow, or like some sort of mental rule of thumb, expect every line of code to be read 5 times on completely different occasions. So every line that you write is read 5 times. Let's make it as easy as possible to understand. But not at all costs. Like, we don't have to super optimize for readability. Think, roughly 5x until you found, through your own experience, maybe a more accurate number than 5x. But 5x is how I think about it. So one kind of example here, a simple example for empathy, is writing helpful assertion messages. Now take a look at the snippet. In this case, we rely on Testify to generate a good assertion message if the test fails. It looks pretty straightforward, but there's actually not one, but 2 bugs in this code that you can avoid if instead you use the standard library to write your own assertion messages. Are you able to spot the bugs? I'll give you a couple of seconds to check it out. All right, spoilers incoming. Now, by writing the assertions using the standard library, you're going to be more conscious that errors should be reported using fatal F. And in the previous example, if I go back real quick, you see that it's both using assert, whereas in Testify, you would actually have to use require instead. And additionally, by writing the assertion message by hand, we're more conscious about which value is expected and which value is the actual value. Now, in the previous slide, this was actually flipped. The Testify library expects the expected value to be on the left and the actual value to be on the right, but we accidentally flipped it here. Speaking from experience, I have done this so many times. So that is why I recommend, taking the time. Like it doesn't take you that long to write out an assertion message that is easy to understand and easy to read when there's an error. And of course, that was just one example where employing empathy helps you reduce the time required to read test code. Remember, every line written is read 5 times. So let's think of maybe some other uses where empathy can really help. Spending a little bit of extra time to think about the right variable and function names. It's a lot. It's very easy to just say, oh, A1 equals blah, 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 or A2 equals blah, blah, blah. But thinking of the good names for your methods, thinking of good names for your functions and variables really helps in the long term. Carefully writing code comments when the test code is complex is also very important. In particular, in test harnesses, which is going to be the next tip that I'll share with you, test harnesses should be very well documented because they tend to be a little bit more complicated. Now, while developing, I recommend temporarily changing your production code so that the tests fail, the test you're writing fails. That lets you inspect the error message that shows up and actually read the output that you get from your test, because that is what somebody else might be reading in the future when they're trying to debug something going wrong. A common issue I see here is forgetting to call t.helper and helper functions. You may or may not know this, but if you forget to call t.helper, the location of the test failure is going to be incorrect in the output, which can also confuse IDEs and developers alike. Now, because test code itself doesn't deliver value, it's tempting to not care too much about the quality of test code. But in my experience, that only leads to spending more time writing tests and debugging, etc. So I recommend keeping the quality the same or even higher for test compared to production code. It's a lot easier to make your production code right if you have a lot of confidence in your test code. So for my second tip, it's important to remember that when we're writing Go, the compiler and the runtime is super fast. So higher fidelity tests, such as integration tests, subsystem tests, etc., are typically also very fast to execute. That means that if you invest a little bit of time to prepare, you can build what I call a test harness to make creating new integration tests quick and easy. Now, let's take an example from backend development. For example, for backend development, the idea is that you replace your service dependencies and databases with in-memory fakes for services and local Dockerized instances of, for example, MySQL. The test harness is a collection of application-specific utility methods that help developers quickly write reliable integration tests. Now, this is all a bit fluffy, so let me give you an actual example of what writing a unit test or writing an integration test using a test harness would actually look like. So this is a snippet that I've slightly altered from another personal project that I have. So this is genuinely kind of the methods that I would have on my test harness. But yeah, let's just walk through it and take a look. So we start by creating a new integration test called IT. This constructor actually does a lot of the heavy lifting of setting up the application and doing cleanup code once the test is done. This is the first and only place that we need the T variable for this integration test. And you can even get away with never using the T variable, but that's not necessarily a goal. We then take advantage of an application-specific method on it, or IT, called register new test user. That lets us create a new test user very easily so that we can use it in our integration tests. And we then verify that without logging in, the user is unable to use this particular endpoint that we are testing. Of course, this is just one test case, but you can imagine with a test harness in place, developers can spend much less time writing good quality integration tests while still making them super easy to read, allowing developers to spend much more time writing value-delivering production code. Remember, it's all about improving this profit ratio, as in spend less time writing tests, spend more time writing the stuff that actually delivers value. Here are some further tips if you decide to actually implement a test harness in your own application. Here are some tips for writing these that I've kind of gathered over the years. Keep in mind that it's not just some package or utility functions for unit testing. This is a type, usually a struct with methods on it. Make it specific to integration testing. Make it specific to your application. For example, in the previous example we had, this register new test user. You can also take advantage of observability features such as logging and metrics to keep track of when some async process is finished. In Go, we use a lot of Go routines. Some of them you don't necessarily care about a returned value. So what you can do is look for a log, look for some sort of metric to be recorded, and at that point, you can make your assertions in your test. It's also super valuable to use this particular technique if you are testing something like a pub/sub subscriber. Another point is I recommend wrapping testing.t in, as well as embedding it, allowing you to very easily create test helpers on the functions per test instead of having to update the test harness every time you want a new kind of utility functions. Again, it's not a collection of utility functions, so you can have separate utility functions in your, in your Go code or in your tests, and just call it.helper if you embed it. Again, the constructor does a lot of the heavy lifting. For example, it will clean the DB before each run and performs DI setup and inject service fakes, etc. So try and keep it fast, but also, whenever possible, try and make it lazy loaded. And when there's an error in the harness itself, it's kind of awkward for developers who might not know about the internals of the harness to understand what's going on. So make sure you use very helpful error messages. One thing that I have a lot is I use Docker to create my databases, and then I have an error message to say, hey, if I can't connect to my database, it's probably because I forgot to run Docker compose up. So it's just a friendly message there. My third tip is on test doubles. There are actually three kinds of test doubles. There's stubs, mocks, and fakes. And I'm guessing if you're like most of the code that I've written, most of the code that I've seen, you've probably only ever used one being mocks, because they're so powerful. And yes, mocks like GoMock are extremely powerful, but this power comes with a lot of complexity as well. First of all, you have to generate them usually in Go, which requires a code base that can be parsed, not as in the code has to compile, which isn't necessarily the case if you're doing some sort of big refactor and you want to, I don't know, change the variable name or a method name all over the place. And since they are generated files, they're also separate files, which means you have to carefully consider the package structure as well. And if in the future you need to replace one mocking framework with another, that could be a very time-consuming chore. Stubs, on the other hand, are typically written by hand. They're simple structs that store a value and return it in an interface method. A lot of long-term complexity from mocks can be saved by using stubs instead. especially when you don't need expectations of which method on the mock was called. And then the third kind is what we call fakes. These are in-memory, it could be like in-memory databases or file systems. They are quite complex, so don't create them yourself unless it's absolutely necessary. But when you can use them, try to use them because they offer great fidelity, meaning a lot of real-life consequences of the application behavior shows up in your test, which is great. And my fourth tip is around table-driven tests. I'm sure many of you have said, oh yeah, you should use table-driven tests. You should use table-driven tests. I fully agree. They are super powerful, super useful, but not everything needs to go into the same table. So the key thing to keep in mind here is to make your table-driven tests actually look like a table. All right, so one of the things you could do is use multiple tables. One of the things you can do is to use separate subtests for special cases. Now, remember that they're called table-driven tests, and tables have columns and they have rows. So it's a good sign if your table's row fits on a single line. It's not necessarily a requirement, but that's a good sign that you're writing a good test table. If you've seen tests with large tables in the past, you're probably familiar with the pain of having to remember the test body. That's much further down, and then you have to scroll up to see what the actual test case was again, and then you keep forgetting which one is what. Yeah, that's also a sign that maybe you need to refactor a little bit here. So some of the common issues that I've seen that prevent test tables from being actual tables are nested structs. I think there's an auto-generated tool that many IDEs use to like generate unit tests for a function. That's kind of the root cause of a lot of this extremely nested, unnecessary behavior. So what I recommend here is trust in yourself. Trust that you are a better developer and understand your application better than the IDE does, because you are. And another tip here is by splitting error cases and success cases into different subtests, we can usually remove a lot of the complexity of both the test body and the table itself. Another point is that mocking logic and mock constructors, in my opinion, do not belong in test tables. Consider if you can use a stub instead. They're a lot easier to set up and can simplify matters. Alternatively, maybe you should use different subtests. Another thing I see a lot is just unnecessary repetition. For example, if you have a value in your table that is always the same, a common one is context.background, then that doesn't need to go in the table. So let's look at an example here. You can see the before and after here on the left and right. Before, we had a 5-field struct slice, a lot of test cases, each field on multiple lines. In fact, I couldn't even fit the test body into the slide because it will be too tall to read. So compare that to the much shorter implementation on the right. So not only do I have a much shorter table at the bottom, I've also included the bodies for two special cases for subtests, making them very obvious that, hey, these are special cases. In reality, actually doing this kind of refactoring on existing code tends to yield even more extreme cases like this. It's just because I can't fit a lot on a short screen here that I can't show you more. And as for my final tip here is this idea of golden files. This is another testing technique I'm a big fan of. Golden files are high fidelity and easy to maintain, and depending on how you write them, it could even be integrated or added to your application without any Go code for simple APIs, that is. The idea is to store the expected data that you want as a file in your repo, usually under test data. And a lot of the times it's just easy if you can use JSON, pre-printed JSON, because it's very easy to read as well. And these files, they are the responses that your application returns. So if you make a change and you run these golden file tests again, the result would be that there is a diff in the outputted files, which would lead to a test failure. So your solution here is then to either update the golden files with the new correct behavior, or to tweak the bug that you have in your production code. But it's very easy to spot because it's all in a diff. If you want to test some more dynamic APIs using golden files, shameless plug, you can check out the JSON insert library that I've written to give you even more flexibility in verifying JSON data of your APIs. Now, that's it from me. The main thing I hope you take away from today is a new mindset on how to write tests, and only write tests when you're confident that they're profitable long term. And just as a reminder, I'll leave the main ideas from this talk on this slide. And with that, I thank you very much for your time.
Hi, thank you for presentation, Kenbeko-san. Thank you. And so it seems so there is a question on YouTube comment, so I'll pick up this. So do you have any tips or strategies for maintaining tests? I often find that writing tests becomes tedious over time, leading to test decay. So can you answer it?
Yeah, that's a very good point. I feel you. I kind of feel it's a little bit similar to also maintaining production code. And this kind of comes back to what I was saying earlier. Let's have the standard of test code being equivalent or better than production code. For example, one thing that I see a lot of teams miss out on is actually, if they do a pull request review and they get to the test code, they kind of skim it compared to how carefully they would read the production code. Develop a culture in your team to, hey, actually, I'm going to read this test code and I'm going to suggest improvements. So basically include it in your code reviews as well. Run linters on this code. Do all the kind of same techniques that you would use to maintain your production code as well. But yeah, great question. Thank you.
Okay, thanks so much, Kim-san. So, and just a moment. Yeah, okay. So it seems there are no other questions. So, okay, thank you for presentation, Kim-san.
Thank you very much.
Okay, let's move to the next presentation. So next presentation is from by Task-san. So this is 34 recap interface internals. Okay, so はい、じゃあ発表よろしくお願いします。
インターフェースの内部処理に少しだけ詳しくなると題してタスクが発表します。まず自己紹介ですね。バックエンドエンジニアをしています。タスクです。興味分野としては、バックエンドと Web セキュリティになります。で、はじめに2つ断りをしておきます。1つ目が、発表の中で登場するアセンブリは、基本的に Linux AMD64 を仮定してほしいということです。Go には疑似アセンブリもあるんですけど、それは基本的には登場しません。混同するので。で、2つ目が、コンピュータサイエンスや Go の基本文法に関する事柄は深くは説明しないということですね。はい。一応簡単な説明を挟む予定なので、何か疑問点があれば YouTube ライブのコメントの方で、はい、残していただければ、こちらは録画となっているので、明日、僕自身が、コメントには対応できるかなと思います。はい。では、本題の方に入っていきましょう。そもそもなんですけど、関数呼び出しってどう実行されるでしょうか？いや、何を当たり前のことを言ってるんだって思うかもしれないんですけど、僕が聞いているのは、Go のコードをビルドして、バイナリになった状態で、どういう風な呼び出しがされるかっていうことですね。はい。例えばですけど、こういうコードがあったときに、メイン関数の say というものを書いたら、当然ここが呼ばれるものだと思ってるじゃないですか。はい。内部的にどう呼ばれているかっていうところを考えたことありますか？はい。じゃあ実際に、見てみるとよくて、今見えているコードが、先ほどのコードですね。で、これを、今回は、GDB と呼ばれるデバッグを使って、内部的にどういう命令が呼ばれるかみたいなものを見ていきたいと思います。まずビルドですね。はい。で、ビルドするときに、今、-n-l というオプションを使いました。で、これが、最適化無効にするコマンドというかオプションで、 で、こっちが、インライニングを無効化する、オプション、フラグですね。で、これを設定してあげて、GDB で、実行してあげることで、この途中の場所まで実行して、処理を止めてあげて、で、その止めた場所で、メモリの内部を見るであったりとか、あとは変数の値を見るであったりとか、そういうことができるようになります。今回は、メイン関数のこの正の部分でどういう処理が行われているかを見たいので、ブレイクポイントと呼ばれる、途中で止まってほしい部分を設定してあげて、実行しますと。すると、今、スレッド1が、ブレイクポイントにヒットしましたと書かれていて、ファンクメインですね。だから、ここの呼び出しで止まっていることがわかります。で、僕が見たいのは次の行なので、一旦次の行に移ってあげて、はい。で、ここで、これから呼ばれる、命令がどうなっているかを見ます。で、先に答えを言っておくと、この3つですね。リア命令から、ムーブ命令、コール命令、この3つの命令で、関数呼び出しが行われています。はい。で、関数呼び出しを行うときに、ルールみたいなのが存在するんですけど、なんて言うんだろう。この場合は、引数、関数の引数ですね。こういうハローみたいなものを設定してあげた上で、行き先の、アドレス、これをコールで呼び出してあげることで、こういうふうに、こっちの正関数を呼べるような仕組みになっていますと。で、それと、アセンブリの読み方なんですけど、アセンブリは基本的に、いろんな記法がある中で、今回使う記法は、最初に命令が来て、で、その後引数を渡すみたいな形ですね。例えば、このリア命令、リードエフェクティブアドレスの場合だと、この RAX というレジスタに対して、この RIP プラス 0x11A6E みたいな、それを計算した中身の値を、RAX というレジスタに入れるみたいな命令で読み解きます。で、これは今回、引数っていうふうに先ほど話したので、実際にこの 0x478603 というところに、ハローという文字列のポインターが入っているはずです。実際に見てみましょう。一応、こういうふうに、こうですね。これで、この478603からのメモリにどういうデータが入っているか見れるんですけど、今回は、文字列として見たいので、ストリングとして表示しました。ですると、こういうふうにハローっていうふうに、文字列が入っているんで、これがちゃんと引数の、ハロー、文字列として渡せていることがわかります。はい。で、次に、このコール命令ですね。これもなんていうか、アドレスが書かれているんですけど、実際に、今回は、デバッグが優しいので、main.say っていう、シンボルに対して、マップされている値っていうことがわかるんですけど、これも実際に、バイナリを逆アセンブルすることでわかります。で、逆アセンブルしたいときは、こういうふうなオブジェダンクって呼ばれる、コマンドが使えます。で、これを使ってあげて、今回の 466B20 を見てあげると、はい。こういうふうに、main.say と呼ばれる関数のシンボルと一致していることがわかるので、ここにジャンプしてあげる、ここをコールしてあげると、ここが呼び出されるので、関数的には、say が呼ばれるっていう、そういう流れになりますね。はい。良さそうです。で、実際に、このまま処理を続けてあげると、はい。こういうふうにハローっていうふうに呼び出せていることがわかります。はい。なので、答えとしては、こういう3つの命令を呼び出してあげると、実行できるというか、実行される、関数呼び出しが実行されるという流れになります。はい。じゃあ、では、今回の本題なんですけど、インターフェースを介した呼び出しってどう実行されるでしょうか？いや、さっき関数呼び出しやったんだから、インターフェースも同じようにしてるんじゃないかって思うかもしれないんですけど、関数呼び出しとインターフェースを介した呼び出しでは明らかな違いが一つあります。でそれは、実際のコードを見ると分かりやすいと思うんですけど、ですね。インターフェース。はい。今回は分かりやすいように、こういう io.reader と呼ばれる変数 R に対して、os.open。これは os.file のポインターが入るんですけど、そういうものが入る例であったり、であとは bytes.buffer ですね。これが入る可能性もあるので、そういう例2つ用意しました。で、これを見ていると、この r.read っていうものが、ここ呼ばれるまで、なんかどの、メソッドを参照するかっていうのが、実行されるまでわからないっていうことをイメージつきますかね。つまり、動的に値が変化するっていうところが大きな違いなんですね。いや、なんか、これを聞いていると、賢い人はコンパイルとかビルドしたら、この R っていうものが、 この os.open の値にしかバインドされないから、いやここも正直固定できるんじゃないかみたいな。呼び出しのメソッド固定できるんじゃないかと思うかもしれないんですけど、なんか例えば僕がすごいなんか変な、すごい意地悪な書き方をして、なんかこういうふうなゴルーチンを作ってあげて、この R に、ストリングス、ニューリーダーみたいな。ちょっと目的がよくわかんないんですけど、こういうふうな書き方をしたとすると、この r.read、21行目の r.read が呼び出される瞬間、こちらの os.open で入っている、os. ファイルのポインターがここで呼び出されるのか、それともこっちのゴルーチンで含まれる、なんか、ストリングスリーダーの、リードメソッドが呼び出されるのか、実行されるまでわからないですよね。どっちも可能性あります。こういうこともあるので、基本的にインターフェースの呼び出しっていうのは、実行時までわからないんですね。なので、さっきみたいな、そうですね。はい。こっちみたいな、この静的なアドレスに対するコールっていうものが、インターフェースではできないと。はい。だから、じゃあどうやって実行するんでしょうというのが、今回の主題になってきます。はい。なので、発表の目的としては、インターフェースの処理がどのように実現されているか理解すること。で、想定対象者は、内部処理に興味がある人。で、かつ、Go やコンピューターサイエンスの基本的な部分っていうものを理解している人になります。一応、この下の部分はなるべくカバーというか、するつもりではあります。はい。一応流れとしては、それを理解してもらうために、インターフェースの内部処理に必要なステップをシェアしますと。で、これが基本的に話のメインですね。で、一応、Go の 1.22 で、インターフェースの、インターフェースに関わるタイプアサーションとタイプスイッチが高速化されたんですけど、その仕組みについて少しシェアします。で、最後にまとめですね。それをする流れになります。はい。じゃあ、最初の、内部処理に必要なステップから話していくんですけど、先に結論を出しておきます。答えとしては5ステップですね。まず、インターフェースに含まれている型というものを取得します。で、その型を取得できると、メソッドの一覧を取得できるので、そのメソッドの一覧の中から、正しい名前の、メソッド情報を取得します。で、その後、メソッド情報が1に特定できるので、バイナリにおけるどのアドレスに、マップされているかを取得して、で、そのアドレスが分かれば、さっきみたいに、コール命令で呼び出せばいいと、そういう流れになります。これだけ聞いてもよく分からないと思うので、実際のコードを見て考えてみましょうと。こういうふうな、io.reader の変数 R があったときに、そこにストリングスニューリーダーを入れる例。で、その後、リードメソッドを呼び出す。こういう流れの場合は、まずインターフェースに含まれている方は何でしょうというと、ストリングスニューリーダーで入るものなので、ストリングスリーダーのポインターになります。で、次に、メソッド一覧は何かというと、今回は io.reader なので、含んでいるメソッドはリードメソッドだけだから、リードになります。はい。で、正しい名前のメソッド情報も、リードがマップされているものなので、ストリングスのリーダーの、リード。で、これが分かると、このリードがあるアドレスを取ってくればよくて、で、最後に、コールメールでこのアドレスを呼んであげれば、良さそうだと。そういう流れになりますね。はい。じゃあ、これを実際にどうやってやっているかっていう部分を、もう少し深掘ってみましょう。まず前提として、インターフェースの、汎用的な使われ方ですね。こういう空のインターフェース。今では any っていうふうに書くこともできるんですけど、空のメソッドセットを持つインターフェースについて考えてみましょうと。で、こちらは、2つのフィールドで実現されています。タイプ E フェースで書かれている通り、エンプティインターフェースの略で、1つ目のフィールドが、型情報を含むタイプですね。で、2つ目が、データ自体を指すアンセーフポインターを持つ、データになります。はい。じゃあまずは、このデータの方から見ていきましょう。はい。データ参照は、アンセーフポインターで持つので、例えば、こういうふうな、エンプティインターフェースの i という変数があったときに、長さ3のアレイですね。こういうデータ構造があった場合、その先頭を指す、そういう形になります。で、この i は、比較的すぐに、終わる変数なので、レジスタもしくはスタックに積まれて、このアレイみたいな、割と長期オブジェクトに関しては、ヒープに積まれるみたいな形ですね。で、その後一応インターフェース的には、すべての任意の型を、受け付けられるので、長さ4のフロート64の、アレイがあった場合、これを代入されたら、データのポインターがこっちに来ますと。で、もともと使われていた1、2、3みたいな、このアレイはもう参照されなくなっているので、ガベージコレクターのスイープ対象になって、メモリ解放される 流れになります。はい。で、一応ここで最適化を挟んでいて、一部。例えば、最初に話していたような、ストリングスニューリーダーみたいな場合ですね。で、これって2回のデリファレンスが発生するイメージつきますかね。最初はデータから愚直にそのままストリングスリーダーの、ポインターを参照してしまうと、1回ポインターでデリファレンスしてから、安静ポインターでデリファレンスしてから、ストリングスリーダーでもう1回デリファレンスするんで、アクセスのために2回の、命令というかが必要になってしまうという、問題というか、改善できる、部分があります。はい。なので、一応、現状の実装では、こういうポインターを持っている場合は、ストリングスリーダーでそのまま、ここのデータ部から、直接本体のデータにアクセスというか、ポインターが指すように、しているそうです。はい。で、あとは、もう一つ最適化の方法があって、でそれは、こういうふうな、小さいデータ、Go において、こういうリテラルというか、小さいルールの値は、32ビットで保持されてるんですけど、そういう小さな値は、ヒープでこういうふうに持つんじゃなくて、そのままこのデータの中に直接入れてしまうみたいな持ち方をするそうです。ただ、こういう話は、Go の内部的に Go がやってくれることなんで、僕ら書く場合は、特に気にしなくて良いそうです。はい。で、エンプティインターフェースのこのデータの持ち方を話した次は、型情報の持ち方について話していきます。はい、で、型情報は、このさっき言ってたデータの他にあるタイプの方で、持ちますと。で、型情報を表すために、静的データのタイプディスクリプターというものを参照します。で、タイプディスクリプターって何かっていうと、こういうふうにインターフェースのタイプで、この共通のタイプっていうエンベディッドストラクトみたいなのを持っていて、で、具体的には、型のサイズ、ここに書いてあるサイズとか、ポインターフィールド、あとは文字列表現で書くとどうなるかとか、型に対して、イコールイコールを、どう、なんていうの、評価するかとか、あと今回、使いたいメソッドのリストですね。こういう、拡張された i メソッドみたいなのも持っています。はい、で、この、例えば具象型からインターフェースの変換をする場合ですね。例えば、こういう、S みたいな変数、ストリングスリーダーのポインターがあった場合、それを、エンプティインターフェースに代入する例を考えてみましょうと。すると、もともと具象型のデータだったので、実データが存在しているのと、このストリングスリーダーと呼ばれる型情報が存在しているはずなので、それぞれ、データは、実データのこの安静ポインターをここに入れてあげて、で、型情報は、タイプディスクリプターを、ここの参照先に入れてあげればいいでしょうと。そういう感じですね。はい。あとは型アサーションの場合も、どうやってやるんだろうっていうと、型アサーションの場合は、こういうエンプティインターフェースに入っている、i ドット、カッコで、こういう形で書くと思います。で、この時何が起きているかというと、もともとあるのが、ここまでですね。この i で持っている、タイプのタイプディスクリプターなんですけど、このタイプディスクリプターと、このアサーションしたい、型アサーションしたい、型のタイプディスクリプターが、一致しているかどうかを比較してあげて、一致してたらいいよねっていう、そういう流れですね。はい。であとは最後に、よく皆さん使うエラーの処理でニルチェックなんですけど、これも、エラーという変数の中の、タイプディスクリプターを見てあげて、ニルと比較するっていうところですね。一応、省略しましたけど、エラーというのは、インターフェース、エラーという、メソッドを持つインターフェースで定義されるものなので、こちらもインターフェースの、流儀に従ってチェックされるという、流れになります。はい。一応、インターフェースのタイプディスクリプターに関してなんですけど、1位でなくてはならないという制約があります。で、これは理由として、複数存在すると、参照先が1位に定まらないためですね。例えば、複数一つの、型のタイプディスクリプターが存在してしまうことを想像してほしいんですけど、ある、なんて言うんだろう、インターフェースからは、この型はこうだって言ってるのに、別のインターフェースからは違う型っていうふうに言われてしまうと、それって、壊れるのが容易に想像できますよね。はい。だから、重複がある場合とか、変な、持ち方をしている場合は、そもそもビルドの時点でわかるので、重複がある場合は、リンカによって排除されたりとかするんですけど、一応、リフレクトパッケージとかプログインパッケージみたいなものを利用する場合は、これが壊せてしまうので、壊さないように注意する必要があるという、話ですね。はい。一応余談なんですけど、別の言語での型情報の持ち方みたいなのもあって、Go は基本的に、というか、そもそもクラスという概念がないですね。ただ、例えば C++ とかだと、継承、クラスがあるから、継承っていう概念があって、でその場合、例えば、こういうベースクラスがあって、関数 FG みたいなものがあった場合、これを継承する、なんていう B1 みたいな、 ベースクラスを継承する B1 みたいなクラスがあった場合、この G というものは実装してないと、このベースクラスの方を参照するんですね。はい。で、これを実現する方法として、バーチャルメソッドテーブルっていうのを持っているそうで、こういうバーチャルメソッドテーブルっていうものを、クラスが、ごとに持っているから、実現できるみたいな例もあるそうです。面白そうなら参照してみてください。はい。で、一応元の話に戻ると、インターフェースの最初の型の取得ですね。これができましたと。はい。じゃあ残りどうしようかって考えたときに、ちょっとコスト高そうですよね。メソッドの一覧全部取得して、で、その中から一つ一つ探してみたいな。で、これって事前に計算できないだろうかという気持ちになってきますね。はい。で、ただ、できたとしても、保持するスペースがなさそうだと。さっきのタイプの情報はこのタイプのポインターで先に出さないといけないし、データはデータでもこれは完結したデータ構造なんで、もうこれ以上どうしようもないっていうふうに思うんですけど、はい。ここでインターフェーステーブルというのを導入しようっていう話ですね。はい。今はデータは実データで、タイプはタイプディスクリプターを参照してるんですけど、ここの間に中間のインターフェーステーブルっていうものを導入しましょうと。で、タイプ自体はこれを参照して、で、さらに中にあるタイプというものがタイプディスクリプターを参照するようにすれば、ここを拡張することで、さらにデータを持つことができるようになりますと。はい。で、それが、今回新しくというか、元からあるんですけど、ノンエンプティインターフェースという概念ですね。元々の、エンプティインターフェースは、こういう構造を持っているんですけど、ノンエンプティインターフェース、つまりインターフェーステーブルをこういうふうに持つようになった、ストラクトは、こういう、この iTab っていうものの型情報が、この iTab っていうストラクトで定義されていて、例えばインターフェースタイプの情報であったりとか、また元々のタイプ情報であったりとか、あとは、ファンですね。これが、メソッドの、一覧というか、になるんですけど、そういう情報を拡張して持てるようになりますと。はい。これによって、先ほど話していた、メソッドのリストみたいなものを、高速にというか、キャッシュというか先に計算しておくことができるっていう嬉しさがあります。で、これによって、具体的な例を考えてみると、ストリングスニューリーダーだったら、インターという部分にインターフェースの情報が入るので、この例だと io.reader が入りますね。であとはタイプだと、ストリングスリーダーという具象型の、型のポインターが入って、で、ハッシュというのは、このタイプの中にあるハッシュというものを参照するそうなんで、このハッシュを参照して、であとはファン。これは今回 io.reader はリードメソッドだけを、実装しているものなので、ストリングスのリーダー .read、これを持つみたいな流れになります。はい。で、これを導入したとき、もともとあった、この、なんていうんだ、インターフェース。今回はノンエンプティインターフェースなんですけど、それの持ち方っていうのは、データの部分は変わらないんですけど、もともとタイプしかなかったものが、タブ、インターフェーステーブルの略で、こういうふうにインターフェーステーブルを参照してあげて、さらに多くのデータを持てるようになりましたと。はい。なので、こういうふうな io.reader のこの任意の方に対しても、こういうふうに、参照できるようになりましたという話ですね。はい。じゃあ、これを持ったところで、実際にどういう処理が、実行されるかっていうことについて、考えてというか確認してみましょう。はい。で一応、ソースコードは、ないですかね。ここにあるんですけど、今回分かりやすいように、こういう、io.reader と呼ばれる、インターフェースを引数として、リードメソッドを呼び出すみたいな、簡単な、構造にしてみましたと。で、それと、ですね、こういうふうに、マニフェイス。また同じようにビルドしてあげて、GDB で見てみると、今回見たいのは、この r.read の呼び出しの部分なんで、ここにブレイクポイントを貼りますと。ブレイクのメイン .c ですね。はい。で、実行してあげると、今、ファンク G だからここに来ました。で、もう少し進んであげて、はい。今、r.read の前まで来ました。で、ここで、命令を見たいんですけど、命令を見てみると何がわかるかというと、ですね。はい。今ここにいて、いろいろ、この XOR、EBX とか、この EBX ってレジスタなんですけど、同じレジスタを XOR すると当然0になるじゃないですか。だからここら辺の処理とかは、一旦本質ではないので飛ばしてよくて、今回見なくちゃいけないのが、コール命令で呼ばれるこの RDX っていう あとは、引数の設定で必要な、もう RAX という、このムーブ命令の部分ですね。はい。で一旦、例えば、じゃあこれ、まとめてみると、何が起きているかっていうふうなことを考えると、ですね、まず、RDX、こいつが知りたいんですけど、RDX にどういう値が入っているかは、ここですね。まず、move の RDX キーワードポイント、RDX プラ 0x18 なので、RDX というものには、今、もともと、RDX というものが入っていて、それに、0x18 足しましたと。で、足して、そのポインターですね。それが、ここに入るはず。っていうことがわかります。これ、キーワードポインターなんで、参照しているってことですね。で、次に、この RX に関しては、ここですね。ここは、RSP プラ 0x50 なんで、RSP プラ 0x50。こういうデータが入っているはず。で、さらに、ここで RDX って参照されているものって、ここで move 命令でもう一回、なんていうの、アサインされてるんです。だから、RDX っていうものは、これか。RSP プラ 0x48 のポイントなんで、RSP プラ 0x48。こうですね。はい。こういう、流れで値が入っていることがわかります。じゃあ実際にこの流れを追っていきましょうと。まず RDX の方が、これが、呼び出される。あ、間違ってしまった。これが、コールドアドレス。で、こっちが、アーギュメントですね。で、実際にデータをまず見てみると、RSP プラ 0x48 になって、ですね。はい。で、これを計算すると、0x4972F28 になるらしいです。はい、で、これが今 RDX 一つ目の値なんで、次はこっちに 0x497FE8 を入れて、0x18 を足したもののポインターですね。だから、これプラス 0x18 したもの。これを見てみると、どうやら 4678E0 っていう値がここに入っているっぽいです。で、この値って何なんだろうっていうことを確認してみると、はい。ストリングスリーダーの、リードメソッドのアドレスであることがわかるので、これは、正しく、ストリングスリーダーの、リードメソッドを参照できていることがわかります。はい。で、次に、RX に入るアーギュメントの方を確認してみると、RSP プラ 0x50 ですね。でこれは、C86020 みたいな値が入っているんですけど、これって、ストリングスニューリーダーの、もので得られる、これです。リーダーというポインターを参照しているんですけど、で、こちらの定義を見に行くと、こういうふうに呼び出されるストリングの部分が先頭に入っていることがわかるんで、これも本当にそうなのかっていうことを確認するために、このデータの中身を見てみます。こっちじゃないな。これで中身を見てあげて、で、中身の先頭に含まれているデータから確認してあげると、はい。こういうふうにホゲっていうふうなデータが入っていますと。で、これって、ニューリーダー、ストリングスニューリーダーに渡した引数の部分と一致していることがわかるんで、引数にレシーバー、アーギュメントというか、レシーバーって書くですね。キーです。レシーバー。はい。こういうふうになってますよという話ですね。はい。はい、で、これで一旦、確認はできたので、ちょっと時間がない気がするんで、元の話に戻ります。なので、今まで話してきた流れ的には、答えとしては、この3つの命令がすごく大事で、この RDX の方、これがさっき言ってた、ここの参照の、こっちか。こっちの部分ですね。で、ここの部分で、実際はさっき言ってたインターフェーステーブル、この RDX っていう処理が、もうこれインターフェーステーブルを指してるんですね。でそこのプラス 0x18 っていうのが、さっき言ってた、これかな。この今、RDX が今ここの線と指していて、ファン を今取りたいわけじゃないですか。だから、ここに参照するためにプラ 0x18 してるみたいな感じですね。で、これがオフセットみたいな形です。で、あと、RX は今回レシーバーを設定しているんですけど、これもさっき言った通り、ストリングスニューリーダーだから、このニューリーダーの、ストリングス .reader のポインターみたいなものが、ここに RX にセットされている。で、最後にこの RDX で、呼び出したい、リードメソッドのアドレスを、設定されているんで、最初の関数呼び出しと同じようなことができる。そういう流れになります。はい。で、あと、一応ちょっと時間ないんですけど、高速に実行するための仕組みとして、Go の 1.22 から、キャッシュ戦略というものが追加されました。でこれは、簡単に言うと、インターフェーステーブルを、キャッシュする、仕組みですね。はい。詳しくは書かれている通りで、ここの、2つがメインだと思うんですけど、興味のある人は見てみてください。一応改善としてはタイプアサーションで約7割程度、タイプスイッチで9割程度の改善が行われたそうです。はい。ちょっと駆け足になってしまったんですけど、まとめとしては、インターフェースはこの以下のステップで実行時に処理されていて、高速化のための工夫としては、データの持ち方、なんかポインターとなんか2回デリファレンスするところは1回のデリファレンスにするようにするとか、あとは、小さいデータはなんかポインターにせずにそのまま持つとか、そういう話であったり、あとはインターフェーステーブルのキャッシュですね。これは最後にちょっとだけ話したんですけど、はい。そういうものもありますという、流れですね。はい。ちょっと伸びてしまったんですけど、以上です。ありがとうございました。
タスクさん発表ありがとうございました。タスクさん、ミートになっちゃってるかもしれない。
はい。
ありがとうございました。
はい。
とてもディープな内容だったと思います。質問をちょっとだけ待ちながら、若干雑談気味ではあるんですが、Goファンコン24、どんな感じでしたか？
どんな面白かったですよ。なんか、はい、コンパイラチームの人とかもなんかフランクに話せましたし、なんか単純に Go 自体が好きな人がたくさんいたんで、雑談してる時間も結構楽しかったなっていう感じですね。
ありがとうございます。なんか他にもなんか興味深い発表ってあったりしました？
他はそうですね、なんか、2週間前くらいにリキャップで、ニューモさんのところで発表させていただいた、なんだっけ、コンパイラを拡張する発表で、コンパイラに構文を追加して、そのバイナリーが生成されるところまで、拡張するっていう発表、それは結構面白かったですね。
ありがとうございます。そうしましたら、X も YouTube コメントも、特に質問はなさそうなので、質問タイムは一旦締めようと思います。改めまして、タスクさん発表ありがとうございました。
はい、ありがとうございました。
ありがとうございました。はい。そうしましたら、次の発表に移りたいと思います。Okay, let's move to the next presentation. So, next presentation is from by Rasran-san. So, this is 24 recap who test the tests in English. Okay, so Rasran-san, okay, so go ahead.
Yeah, thank you so much. So yeah, we had a little break with this internals of interfaces, and I guess we can come back to the tests topic now. So hello everyone, I'm Raslan. I have 6 years of experience in software engineering. Been living for 3.5 years in Japan, and 1.5 years I've been working in Mercari, and same time I've been using Golang. Started kind of recently. Working in a foundation backend team, which is responsible for base backend services like notifications, domain users, etc. Free time playing drums and trying to enjoy Kubernetes and Golang world. Yeah, and we can move on to the GopherCon. Last July, this year we were participating GopherCon conference in Chicago with Tusk-san and some of our other colleagues from Japan as well. You can see some pics from there. Of course, Chicago was not only about the conference, but good views and of course deep dish pizza. But today we will talk not about the deep dish pizza, but some other interesting topics. So let me use slides from the GopherCon for the efficiency. This presentation was made by Daniela Petruzalek, and it's basically about mutation testing. So let's dip into it. So why do we write tests? This is the question that Roger asked in the beginning of his session. Just to remind, this is why we write the test, right? We want to know what code does, and it equals to what it's supposed to do, and that the code doesn't do what it shouldn't be doing, right? But also, we can consider tests as the first client of our code. For example, if you're using TDD, etc. And you can also consider that there is a really strong correlation between the code that you can easily maintain and to the code that easily you can test, right? You can easily read the test cases and you'll be able to understand what it's doing. So as you might know, we have different ways to measure the tests. Like we have the code coverage, which is percentage of how much code is covered with the tests, and test coverage is percentage of how much of the functionality tested. But we should be careful, because if a metric becomes a goal, stops being a good metric. So we should be really careful trying to achieve this, some El Dorado of the test coverage, like, oh, we need to have 70, 80, 90%, etc. And here is the example of small function that just doing division. We have dividend, divisor, etc. Pretty easy, right? But we can easily fake the coverage of this code. We can just write the test that doesn't check anything, no checking the output of this methods for both 0 and 1s of the dividers, and we'll have 100% coverage. Wow, we achieved the goal. Let me quickly run this code just to be sure. So this is the same function here, and we have the same tests. So let me go into the folder, and we can run Go test with coverage. Yeah, 100%. That's amazing, right? So yeah, let me zoom it a little bit. That's wonderful. That's the goal that we had before, right? But I don't think it's correct way how we write tests in the software engineering, right? For example, if we come back to the demo, under second folder, we have proper tests. As you can see here, we have testing divide, which is 1. We check the output with the fatal F, as Roger mentioned. We're checking expected result. We also check the error thrown when we try to divide number by 0. And yeah, if we go there once again and run the test, coverage 100%. So yeah, this is looks like a truth for us. But now we can move on to the mutation testing. What is this? How we should eat it? Which spices do we use? So mutation testing for me, was a new technique and that we can use to find flaws in our tests when we introduce small changes, modifications into the initial code, and we run the same test suite after that. So what are possible mutations we can do? So for example, we can reverse Boolean operators. We can change like math operators, like we can replace multiplication with division or sum with subtraction, etc., etc. Another great example is that we can force Boolean expressions to be true all the time or false all the time. Same for the statement deletion. We can remove whole block of else, for example, or whole function body and test that. And yeah, we can change the value of numbers we have in a code. For example, if we do some math calculations, we can change some constants, for example, from small to big and big to small, etc., etc. So how we should know if our mutation tests are good or bad? So basically, if the initial test after mutation is failing, then we say that mutant was killed. And if the initial test is still passing even after the mutation, we say that mutant survived. And the quality of the test suite will be measured by the number of how many mutants were killed during the test. So we have another example here. As I said before, we can change booleans, write expressions, etc. So here we're checking if the visor is equal to 0 and we throw the error initially. But when we do the mutation, we introduce the change of the Boolean operator. So in this case, we will not be checking this 0. And so this is a small mutation we can introduce. And second one, we will replace division with a multiplication and see what happens next. So yeah, let me go to the code once again. We can go to the example number 3. Here it will be having replacing of the Boolean operator. So you can see we manually introduced this mutation here. Yeah, let me zoom, sorry for that. Yeah, we introduced replacement of the check for the 0 of the visor. Yeah, and let me run the tests in this repo, this folder. Oops, we can see that test is failing. So this is actually what we expect to do, right? Because if it's failing, then mutant was killed. This is good for us. And the same, let's do with the example number 4, where we have multiplication instead of a division. Let's go to that folder and run the tests. Oops, somehow it passes. So not all the mutants were killed when we introduced those two mutations. As you can see in this slide, yeah, we have 50% of a mutation score, which were shown during the demo. We can see that both tests were killed, both mutations were killed in the first mutation when we reversed check for the 0 of division, right? And in the second one, both tests were passing, and so that means that mutants survived. So in this case, yeah, it's 50%. But you might ask, you did that manually, guy. How we can do that in Golang, right? And this is a really good question. And this is, we can use help of the abstract syntax trees. So we don't need to know a lot of this deeper internals of the AST, but what we should know that initially we write a code, then some magic happens. We get the AST, this syntax trees, then another magic happens, and we have our binaries to execute. That's all that we need to know. So at this slide, we can see the binary expression, how it looks like inside of the AST. So each expression is represented with the operands and operator that we have. So for example, here it will be the sum. So we add B to A. So pretty simple. And this is the screenshot from the library you can see here. Moving on, we can use AST to make these mutations. And for example, we can replace our operator here. And instead of the sum, we can use subtraction. Yeah, it sounds pretty simple. So how we can do that overall, like what is the process, how we should do that in Golang or any other language. So we load the code from the disk, we parse it into the AST syntax tree, we apply mutations, replacing operands, etc., etc. Then we write the code back to disk, run the test that we had before, and profit. And then we just calculate number of mutants that survive. So let me go back to the demo. And first of all, let me show you AST example. So here we have pretty similar code, the same division here. And in the main file, we're doing the parsing of this div code. So here we have file name. We are using a token file set to have the set of the tokens when file will be parsed. Then we parse our initial div.go code into the file. And after that, we can apply mutations. Here we don't do anything. We just send the same code to the mutations folder here. And yeah, that's it. This is just a simple process when we parse the code into the AST and write it to the disk back. Nothing super complicated. So let me go to this folder and let it run. And here in the mutation, you can see that this is pretty the same code, right? Even the comments were saved. Let me zoom it a little bit. Yeah, so it's all the same. So we can move on and we can do the funny things finally. We can do some mutations. This is what we can see in the next example here. So the beginning of the code is pretty similar. We just parse the file into tokens, getting the AST syntax tree, that's it. And after that, we have this AST util library that we can use to apply different mutations. But initially, it's just modifications of the syntax tree. So here you can see that we apply this change binary operator. But if we go down, we can see that we manually define this function. So what it does, it gets the token from the syntax tree. And if this token represents a binary expression, it just changes it. For example, initially, if we go to library, it was division initially, right? But here we replace our operation with multiplication. So this is pretty simple. Another example here, similar function, is to reverse if condition. Same logic. We're getting the token node from the syntax tree, and if it's if statement, we do the reverse of it. Yeah, that's all. So let's take a look how it works. Here we have our initial code, similar divide, checking if divisor equals 0, and we divide it. Pretty simple. In mutations, you can see nothing here. So let me go to that direction. Okay. And let me run. Okay. Now we can see that we have similar div.go file, but now we have replaced division with multiplication. Wow, it's automated. We shouldn't do that manually anymore. That's really nice. So what else left? We did that mutation, and we should run the test and check how many mutants survived, right? So we can go here on the directory number 7, and here you can see like all the similar code, but from now we'll be running some tests. We have function to run test. It's in the main, which it does. It just runs the Go test in the directory where we're in, and yeah, that's pretty much it. So if we do that, go back there. So run the test. Wow, somehow both of them passed, but we did a mutation, right? And it's pretty obvious that in this case, we're running our tests against our initial div.go file, not the one that we saved to the disk in the mutation folder. So what we should do in this situation, so there is a little flag in Golang Go test, which allows you to use files from another folders, like another locations, and test them. So basically, this flag is overlay, and we can check our folder number 8 with these examples. And here we can see that the only difference we now have is that we have this overlay and we have a map of which files we should use. And in the run test, you can see that we execute the command go test JSON and overlay, and we put the overlay, which should be actually just a JSON map, which we can see here. So it says that when we want to use div.go, for example, our initial code, what we want to test, we should replace it by mutations/div.go, and that file with code will be tested. So yeah, let's check it out. Let me go back. Overlays, and yeah, let me run once again. Okay, we have better results. One thing I want to highlight that in this directory, number 8, we also have a function to parse results of the output of the tests. For example, if it contains fail, it will be named as killed, and vice versa. And in this case, finally, we can see that, okay, this mutant was killed, and this one survived somehow, as we've seen before when we introduced our changes manually. And just double checking mutations. Yeah, it's still there. We have multiplication here. Looks good. So this is the whole thing was kind of introduction to mutation testing, right? We don't need to write all the libraries for this from the scratch. And of course, there are some solutions for the Golang. For example, they have Go Mutasting, Go Mutates, Lean, and the Gremlins, which looks more popular according to the author of this talk. And yeah, what we can take away from this talk, we should write our tests for good reasons. We should choose the test inputs wisely and do not ignore the outputs of the function that we're testing. As you might seen before, one mutation is not enough. As you can see, like we introduced 2 mutations and 50% of the mutants survived. But on the other hand, running too many mutations will be really expensive and will take a lot of time. Yeah, and as a highlight, the mutation testing itself in Golang is not really mature yet, but as a community, we can make it happen. Yep. And yeah, that's all from my side today. Thank you so much for your attention.
Okay, thank you for presentation, Arthur. So
Thank you.
thank you. And so we are checking the comments on X and YouTube comments. So currently it seems there are no questions, but so I'd like to ask a question.
Yes, please.
So it's simple question. So how do you feel to try this mutation test?
Yes.
Test in your production code or your code in the future?
Yeah. I was thinking to introduce that to some microservice just to check it. We don't have in our team, we don't have a lot of projects with the, where we do calculation. We can replace, the sums and subtractions. And I think most of the time it will be, reversing Boolean expressions mostly. And for example, even removing the whole else statements. This is the only thing I can see. I might consider this trying Gremlins because it's pretty automated and I haven't touched it a lot. But what I've seen is that you provide your code there and it tries to replace anything it sees. So it's pretty useful, I think. And yeah, we should try. But of course, if it's efficient and not expensive, as Roger mentioned.
I see. Thanks so much. And so it seems this is a not question, but so I would like to pick up this comment. So
Yes.
on YouTube. So from Grabber-Russian, so awesome them. So I finally understood mutation tests. I couldn't understand the concept before.
Thank you
From
so much.
Grabber-Russian. Yes, thanks so much. Okay. Sorry. So I got a question from Kimbiko-san. So does it
Yeah.
support switch cases too?
Wow, that's a good question. I hope so. I mean, in the abstract syntax tree, there should be operands for the switch, right? Switch statement. I don't know how it processes the code we initially have under the hood, but I want to believe.
Okay, thanks so much. So it seems there are no other questions. So let's finish your presentation.
Thank you so much.
Thanks so much. Okay, so the next is the final session. So the final session is from by Akram-san. So Cloud PubSub high speed in-app notification delivery in English. So, okay, Akram-san, please your presentation.
Nico-san. So yeah, hello, good afternoon, everyone. This is me, Akram here, and I will share some of what we in Mercari from notification team use in our implementation of sending notification to all of our Mercari users. So first of all, let me introduce myself. My name is Akram, and I joined Mercari back in April 2024 as a new grad. So earlier this year. And now I'm assigned in the foundation backend team, specifically in the notification side of our team. So yeah, for my presentation, I will keep this short, but just for transparency. So the agenda of my presentation will be first, I will be talking about how the notifications overview is in Mercari, and second, I will try to do like a high view overview of how we implement the notification service in our Mercari application. So yeah, first of all, Foundation backend team's responsibilities are actually including managing notifications in two distinct roles. First is the role of application, and second is the fundamental role. And for the application role in notifications, we need to handle in-app notifications, private message, and also to-do lists, while also managing data processing and also responding to creation and retrieval requests from other microservices, which may use the notification service in Mercari. And the second role, which is the fundamental role for notification, is actually utilizing methods such as email, push notifications, SMS for customer notifications. For all of you who has already familiar in using Mercari application should also know about this kind of notifications that are available in our apps. And then we also need to receive requests from other microservices to send notifications. And the last thing is actually to send notification through our internal API or infrastructure managed by our team. So as you can see in this screenshot on the side, this is how our Mercari app application display the notifications in our application. So yeah, talking about notifications, we actually do have two kinds of sending notifications. The first kind is actually pull-based notification, where our platform, so the notification platform, just store the data in our service, and then the client will actively post notifications based on the customer action. And the second one, which will be mainly discussed in this presentation, is actually the push-based notification. So for this one, our notification platform will directly push the notification to the client, and then the client will receive the notification even passively. So maybe those of you guys who has also used Mercari frequently will also know that we can get an in-app notification and also sometimes notification when we aren't even active using the application itself. So this is the push-based notification example. Okay, talking about push-based notification. So in a hindsight, the way that it works is actually can be represented using this simple diagram. So our platform, which we could say notification microservice, they will have some pops up. In this case, it will act as a kind of worker, which will then send the notification to our client. So for example, this is how we are sending the notification to our mobile apps, as you can see. And yeah, talking about PubSub itself, the producer consumer are something that we have also familiarly known as asynchronous inter-service communication. Is actually something that we notification back foundation backend team, especially the notification service team, leverage to send the push-based notification as has been told before. So for this one, we actually use Google Cloud PubSub, and it is a fully managed real-time messaging service that allows we as the client to send and receive message between independent applications. So by using this Google Cloud PubSub, we are actually trying to do the asynchronous way of doing the programming. And the way that this PubSub work, I will try to explain it briefly in the next section. So yeah, this is how the Google Cloud PubSub structures itself in an overview. So as we can see here, we have this publisher, which will act as some kind of temporary memory where our application will try to pull any new event so that this new event will then try to be used by the subscriber. So the way that the publisher work is that for every kind of subscriber that is actually subscribed to the event or subject, we can say it's subject here, it will then the publisher will then notify the subscriber, so then the subscriber will know how to actually handle the event whenever the event is available to be handled. And this is how we in an overview designed our bulk delivery architecture. So we are using gRPC server, and then we have this intermediary cloud PubSub, which will act as a subscriber, and then as a publisher, and then we will have the worker pods who will then subscribe to the Google Cloud PubSub, and these worker pods will then call or maybe send data through our external API that is used to send the notification data itself to our client. And for a little example, this is how the function or maybe the code of our worker, to make it simply, looks like. So first, we have this context which will be used to actually determine and propagate the cancel if it needs to be canceled for whatever reason. So maybe there's timeout or something goes wrong. And then we will have this message that is actually a channel in Golang. And then we will also use coroutine here to actually pull the message itself So this one is acting as the subscriber, and then for every message that is pulled by the Go routine, it will also be handled by another Go routine that will process the message itself. And yeah, that's basically how we try to implement the architecture of PubSub and then asynchronous sending in this notification domain in Foundation backend team. So as we can see here, by actually trying to implement our notification sending this way, in the past, we have actually had this result. So we had a peak request per day, which is 16.3 million requests per day. And the peak RPS is at 400 RPS. And we can also see that we have quite a big number of requests from our in-app notification. This is being called by our client. So we have like 28 million requests per day, which also peaks at around 480 RPS. And we have another data point, which is like our other endpoint that have a much higher total amount of requests that reach 200 million requests per day, which peaks at 3,600 RPS. And some additional notes. So what I was trying to explain by having this slide over here is that by actually designing the platform or the microservice that handles our specific needs correctly, we can have a quite high enough throughput, as we can see on the data on this slide. And besides actually using PubSub, so for most of the use cases that I have been describing in this entire presentation, most of the bottleneck when we are trying to push the throughput to be higher is actually lies on the database itself. So for this case, we also need to actually pay attention to how we configure our database. In this case, we are actually using Cloud Spanner, which is also included in the ecosystem of Google Cloud Service. And some things to notice actually that for critical functions, so for example, if we are in need of sending a very high amount of notification and we should maybe pre-design our API to have some kind of priority that can be specified when we are calling the API, we need to actually assign this API to have a higher transaction priority so that when the throughput or the RPS is actually increasing or maybe reaching its peak, the transaction could be tried to be done as fast as possible by having it set to the highest transaction priority. And also still related to this point, we also need to design the API itself to actually accommodate priority-based function execution, which as I have already explained, maybe we can try to have some kind of API that can specify which transaction priority that it should use, maybe like the high priority, or sometimes maybe we can be fine with just using the medium or normal priority. And other than that, we also need to actually try and take a look at the specific database that we are using. So in this case, for example, if we are using Cloud Spanner, we do have some other options that we could try and tweak a little bit so that we can have higher performance and getting to the amount of requests that we actually need to get. Yeah, so basically that's what I'm trying to explain in this presentation. And yeah, that's it from me. I give my presentation back to Peranikov-san. Thank you.
Okay, thank you so much. Thank you for presentation, Akram-san. Okay, so we are watching the questions. So from X and YouTube comment again. And so it seems there are no questions now. Okay, so there are no questions. So we are going to finish your session. So thank you for presentation, Akram-san. Thank you. はい、それでは、以上で全ての発表が、終わりました。So, all today's presentation have been finished. それでは、クロージングに入らせていただきたいと思います。はい。こちらの QR コードに、今日のイベントのアンケートがありますので、フィードバックをぜひお願いいたします。You can also access the sub link from this QR code, so please feedback. そして、本日の発表資料については、後日メルカリ Go の、ブログでもまとめて公開される予定なので、そちらもお楽しみください。A summary of today's presentation materials will be posted on Mercari Go's blog at a later date, so please enjoy that as well. はい、そうしましたら、以上で配信を終了したいと思います。本日はご視聴いただきありがとうございました。Thank you for watching today, so please watch again next time. 次回もよろしくお願いします。ありがとうございました。